Hey students, welcome to science class. We're going to be learning all about conduction today. So it's going to be still part of thermal energy and heat. So go ahead and make sure that you have your science textbook scans, pages 96 and 97. We're going to be reading those two pages, and then we're going to review some of the most important concepts through a PowerPoint. And I will also want you to watch a few conduction science experiments. One of them you can actually try at home as well. So it's going to be very exciting. So let's go ahead and read first. If you would rather read alone, that's totally fine. You can skip ahead to the section where we talk about the topics that are discussed in today's reading. But if you would rather read with me, then go ahead and keep watching. Let's go ahead and get started. Heat. Thermal energy is the total kinetic energy of the particles in a substance, but thermal energy of the particles does not usually stay in one place. It moves or transfers. Heat is the transfer of thermal energy from one substance to another substance. Heat always flows from a warmer substance to a cooler one. When this happens, we say that the cooler substance has been heated up, and the cooler substance has gained thermal energy, and the warmer substance has lost thermal energy or cooled. Heat can flow in several ways: conduction, convection, or radiation. And as you probably noticed, today we're going to be talking about conduction, the first one. So conduction is heat transfer that happens when particles bump into each other, but they do not change location, so they don't move around. This often happens in solids, and the particles in a solid are tightly packed together. Think like a Rubik's Cube. And being tightly packed together allows the energy to flow easily between those particles. And when one part of that solid, for example, this part right here, is heated, then the increased thermal energy of the heated particles would cause them to vibrate faster. And as the particles vibrate faster, they cause the particles around them to vibrate faster as well. And then these particles then cause even more particles to vibrate faster until eventually all of the particles of this phone or solid are vibrating faster. So it starts from one part where you put like the heat, and then it starts to transfer. So this process allows thermal energy to flow through the entire object, making it warmer. Now, conduction does not just occur within a substance, it can also occur between different substances. For example, a metal spoon in a cup of hot chocolate heats up through conduction. How? Well, at first the hot chocolate has more thermal energy than the spoon does because the hot chocolate's hotter than the spoon. Then the hot chocolate's particles start to move faster. They actually do move faster than the spoon's particles do because there's more thermal energy. But as the faster hot chocolate particles bump into the slower spoon particles, the spoon is heated, and the hot chocolate particles lose some of the energy and the hot chocolate gets cooler. Meanwhile, the spoon particles gain some energy and get warmer. And in time, the thermal energy will become equal, and the two substances will have the same temperature. So this illustrates it really well. So you have the metal spoon inside the hot chocolate. First, the hot chocolate is obviously hotter, but then as the particles in the hot chocolate start to vibrate and it bumps into the particles in the metal spoon, they will transfer the energy. And then so the particles in the spoon will start to vibrate faster, making the metal spoon heat up. Okay? You might have noticed this when you're stirring something, or if you accidentally left a metal spoon inside a hot drink, the next time you touched it, it might have been warmer, right? So that is conduction happening. And most cooking on a stove top uses conduction. So stove burner heats a pan. The pan heats the food. You would also feel the results of conduction if you touch the hot pan. Ouch. Your hand will be cooler than the hot pan, and the pan would quickly heat up your hand, and the quick transfer of energy would cause the pain and might burn your hand. Now, two things to keep in mind. Number one, conductors. These are things that allow heat to move through them very, very easily. And the best conductors are metals, like the metal spoon. For this reasons, metals like silver, copper, and aluminum are often used when you want to make things hotter really quickly. Many kind of cookware like pans and pots therefore are made of copper or aluminum because when you're cooking you want to make sure that the heat, heats up the food quickly. Insulators are things that do not allow heat to move through them easily. So that's the second word. So insulators are opposites of conductors. They do not allow the heat to go through them easily. Examples: wood, brick, glass, and plastic are good insulators. So cookware like pots, they may have a wooden or plastic handle that acts as an insulator. So if you hold the handle, your hands will not get burned. Okay. You might be surprised to learn that air is also a good insulator. Birds fluff out their feathers on cold days to keep warm, and air between a bird's feathers and its bodies helps insulate the bird from the cold. You use the same principle when you wear several layers of clothing to help keep warm in the winter. Air also helps insulate buildings. Double-paned windows trap the air between the glass panes, and this helps to keep buildings warmer in the winter and cooler in the summer. The trapped air does not easily transfer thermal energy by conduction, and in a similar way, the insulation used in the ceilings and walls of buildings, like our school, often has many pockets of air to reduce heat loss. Okay, a lot of information in just 2 pages. That's why we're only reading 2 pages today. And let's go ahead and go over some of the main concepts here. All right. So basically, heat is transfer of thermal energy from one thing to another thing, just like the spoon to the hot chocolate. And heat always goes from a warmer place to a cooler place. We know this, right? So that's why if you are cold and you go to a fireplace and you put your hand near the fire, the heat will move from the warmer object, which is the fire, to the cooler object, which is you, if you're cold. So always goes from warmer to cooler. The reading also talked about the 3 types of ways that heat moves: conduction, convection, radiation. Today we talked about conduction, which is heat transfer that happens when the particles in a solid, usually, they bump into each other, but they don't change location. They stay in the same place, they just vibrate back and forth. So for example, we have the pot, right? And the fire that heats up the pot. And conduction usually happens in solids. So the 3 states of matter, we talked about solids, liquid, gas. Conduction usually happens in solids. We talked about the hot chocolate example. It could also be the same for coffee. So the particles in the hot coffee will be vibrating really quickly because of the heat. And then the thermal energy will transfer to the cooler spoon, causing the spoon to also get hotter and causing the particles in the spoon to vibrate faster. So basically, it's like moving heat from one place to another. And this is why when you touch like metal pots, it's super hot, because metals are really good conductors. They're really good at basically having the heat travel through them. That's why when your mom cooks or ramen or something like that, and they boil water, you don't want to just hold the metal pot. You're going to drop it and burn your hand. So you use like other things to kind of hold it. Yeah. So like I said, conductors, they're things that allow heat to move through them easily, just like this metal pot. So a lot of things are good conductors, such as aluminum, copper, silver. Aluminum, copper usually is used to make like cookware. That way the fire, when you put the cookware on top of the fire, the conduction happens quickly, so you can get your ramen very quickly. And we also got brass, cast iron, bronze, steel, all that stuff. The opposite would be the insulators. So these guys, they don't allow heat to move through them easily. So the good news is that you probably have insulated homes. So your walls, or if you had like people come in to insulate your walls and your ceilings to make sure that the heat like stays inside. So the insulators will block the heat from moving out of your house to keep you warm. Just like if you're wearing a lot of clothing on top of each other to keep yourself warm and insulate yourself, right? All right, so that was conduction. We're not going to be talking about convection and radiation today. We're going to be talking about those two on Thursday, because today we have to finish our energy for the body project from last week. So you're supposed to keep track of the food that you've been eating, right? And calculate all the calories and things like that. I understand that we got a lot of questions about like how to calculate the calories and stuff. So if you're not able to get the total calories for the exact calories for the food you ate, that's understandable, especially because like we live in Korea, so it's not as easy to find like, I mean, you could use Naver and things like that, but it might have been kind of tricky to count all the calories on Google, for example. But basically, you had to add up all of the calories that you ate for 3 days and write it down. So for example, let's say that our invisible friend Adam from last week calculated all of it and he found out that he ate about 2,000 as an average. Remember how you do this is it says add the 3 daily totals together and then divide it by 3 to find the average. So you should have written down the total calories for example, Friday, Saturday, Sunday. So you add it all up and then divide it by 3 to find the average. So let's say Adam's average was 2,000 calories. Now, you're going to be comparing the average calorie intake with the RMR that you calculated last week, okay? So this will tell us basically how to answer this. So compare your daily average with your adjusted RMR. Do you eat about the same amount of calories as your adjusted RMR? So Adam's RMR was 2,074 and his average calorie intake was 2,000. So it's very, very, very similar. His RMR is like a little bit more, like by 74, but it's not a lot. So he would write, yes, they are about the same. They're similar, right? Now, what do you think would happen to a person who consistently, so this is for someone who usually frequently eats less than his adjusted RMR. So what do you think would happen to somebody who eats less than his RMR? Like almost every single day. Would he gain weight? Would he lose weight? Or would he stay the same? This is a review question from last week. So if you remember, if you eat less than the average calorie intake, or if you eat less than RMR consistently, your RMR, then you're probably going to lose weight. So that is the answer here. All right, so that was just a quick review. We're probably gonna, this is from the future, this is Tuesday, so we probably have already talked about this on yesterday, Monday Zoom, right? But if you're still confused, just let me know and I'll be happy to help you. So yeah, that is it for today's science. Make sure to watch those 2 science experiments. So this one will be, it's really cool. It's going to show you how this, so we got the metal spoon here. It's going to show you how the heat it's going to cause. You can kind of tell like the vibration will be happening inside the spoon and then the objects will start to melt off. And then this one you can actually try at home. Just need 3 different types of spoons. It's to test which one is the best conductor. We already know the answer, right? Metal. So metal spoon, plastic spoon, wooden spoon, and you put a little bit of butter on the end, and then you put hot water inside to see which one will melt faster. If you want to find out, watch the video. All right? Great job, guys, and I will see you in reading class. Bye!